Good morning, class. I just want to welcome you to class today, and I hope everyone had a great day yesterday and are ready for some more learning today. If you will go ahead and get your notebook, your math workbook, and a pencil and be ready for the lesson today, we will go ahead and get started when you are ready. This can pause this video until you are ready, but the sooner we get started, the better it will be. All right, today we're going to start with a video just kind of reviewing what we learned yesterday. There was an introduction video of this, and I feel like we don't need to go into that, but this kind of goes over the formula of volume just to kind of give us a better understanding, just kind of review, and then we'll do some practice to get started with for the day. So pay close attention to this video. There should be no talking. You should not be working on anything else. Just be listening and paying close attention to what has to be said. All right, so we're going to look at, the sub is going to pass out this morning work, and it's both sides. It has 13.1, and then there is page 13.2 on the back. 13.2 is where you're going to use the formula, and then on 13.1 is where you're having to count. Remember, when you're counting, don't forget about some that may be hidden. Okay, and it might not be where you need to do that. So I'm gonna set a timer for 10 minutes, and you are going to work. I'm probably going to give you about 8 of the 10 to work on this, and then we're going to go over it together. So she's going to pass this out, and you are going to begin working on this by yourself. There should not be any talking, and we will go from there. All right, so as we get back started with this or take a look at these, let's check some of these answers together and make sure we're on the same page and we don't have any questions, and maybe we make sure that we understand it to the best of our ability. So looking at these, looking at number one, remember on this side we're just counting, and one thing that I noticed immediately is that there is no units. So if there's no units, that means we're just measuring in cubic units, right? And that's just telling me how many cubes there are. So on this one, we have 1, 2, 3, 4, 5. All I'm doing is counting them for the 5 cubic units. Same thing on this one, 1, 2, 3, 4. So it'd be 4 cubic units. And you see I went ahead and did numbers 3 and number 4 by counting those out, and it's just pretty simple. And these have been easy because we don't have any hidden. We can see every single one of them, even though we can't turn it around or move it around. We can see every cubic unit in there. On number 5, though, if you look at number 5, you see that now they do give us, instead of just being in cubic units, they tell us it's their feet. So they're feet, cubes of feet. So I'm just counting at 1, 2, 3, 4, 5. So this would be 5 feet cubed. And so pretty simple. And you said I did number 6, 9 centimeters cubed. And I went ahead and did number 8, and it's 18, 3, 6, 9, 12, 15, 18. Now, when you get to these right here, you can use the formula. Remember, the formula is volume equals length times width times height. And I liked in the video how they combined the length and the width to equal the base. And we'll kind of get into that in another lesson, but that's something to keep in mind. So if I take 6 times 1 times 3, 6 times 1 is 6, 6 times 3 equals 18. So you see that I can do it this way, or I can just count it. It's really up to you on those. So number 7 is one that I would want to use the formula. Now they're telling you to find the volume, but really when you find the volume, you can do it any way you want. So I could say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and say 16, and there's 4 layers, and do 16 times 4 is 64, and I get 64 inches cubed. Or I can go ahead and do the formula. So this is length, this is width, and this is the height. So 4 times 4 times 4. Well, 4 times 4 is 16, and then I have 16 times 4, which we've already did that. So we see that it's 64 inches cubed. So when you get to a larger figure, it's probably a better idea to use a formula than it is to count it. But you always have the counting as an option. If it's something feasible that you can count. Now, if there was 1,000 of them, it'd be kind of hard to do that, as you know. So let's look at the back of the page. And on the back of the page, let's look at number 1 right here. We're doing volume equals length times width times height. And so for volume, we have 8 times 2 times 2. I went ahead and did 2 times 2 is 4. 8 times 4 is 32. So I get 32 feet cubed. Remember, don't forget the cube part. That will make it wrong, okay? If I put just 32 feet, I might say, oh, that's perimeter, right? But when I put the cube, that says it's telling me how much space it is taking up. Same thing on this one, 6 times 3 times 3. 3 times 3 is 9. 6 times 9 is 54. So I get 54 centimeters cubed. Moving on, this one, 5 times 2 times 4. So we got 5 times 2 is 10. 10 times 4 is 40. So I get 40 inches cubed. And this one, 3 times 2 times 9. We know 3 times 2 is 6. 6 times 9 is 54. So I get 54 centimeters cubed, similar to the other one. So even though these are different shapes, they're still taking up the same amount of space for each one. Number 5 and 6, a little bit larger ones. This is where you want to know the formula so you don't have to count them. We saw number 5 on the other side, 4 times 4 times 4, 4 times 4 times 4, 4 times 4 is 16, 16 times 4. If you remember, that was 64, right? So we have 64 feet cubed. And lastly, we have length times width times height. So 10 times 4 times 5. Well, 10 times, I would do 4 times 5 first, which is 20. And then 10 times 20, which would equal 200. So this would be 200 inches cubed. So why is stuff like this important? Why is finding volume important? Like I said on a previous video, making sure a refrigerator can fit in your home, and that maybe it's a little cubby area. Or let's say that you worked for a shoe company and you need to get boxes that could hold 8 boxes of shoes, 8 pairs of shoes. You would want to make sure the volume of the box, the amount of space inside the box, can fit those shoes and those shoe size. Have you ever gotten an Amazon package and they gave you a huge box and then there was just one little item in it? That was not a good packaging because they didn't utilize the volume of that space appropriately. Now, they could have ran out of boxes, it could be this or that, but that's why there's different sized boxes for different things, because different space is needed depending on the size. So that's just a little review from yesterday. And so now we want to kind of switch gears to learning about something else today. And we'll come back to volume once I'm back at school to go over some things. But what I want you to do right now is turn to your, take out your notebook and turn to your learning target index. And we're going to say, this is the 4th. I want you to write the following. You may have to pause this if you don't have all your stuff right here, but I think you should be all right. And we're going to talk about triangles today. So I can say, I can identify triangles. I can identify triangles. Once you have that done, you can turn to your next clean page and be waiting. But I can identify triangles. So getting to our next clean page, we're going to look at some things. Let's try, we want to write at the top, triangles. And we're going to say this is 14.1. And today is the 4th. Now, most of this should be review for you, but it's if you're like me, we're dealing with things that we don't use all the time. So hopefully this is just a refresher. There might be some new things in there, but identifying triangles is done really a couple ways. And triangles, as you know, it's triangles. That means there's 3 angles involved. And so as we think about triangles, if we can identify the angles, we can identify the type of triangles. So if we focus on the first angle, the most common angle that we see, and probably the easiest to identify, is something called the right angle. Make sure you spell it like that. We don't need right angels, we need right angle. So make sure you spell it correctly. And a right angle is one that's at 90 degrees. So when we think of right angles, we should be thinking about 90 degrees. 90 degrees is kind of like a straight line met by another straight line going in the complete opposite direction. So we have this going into this. And the good thing is, a lot of times when we're dealing with right angles, it's hard to tell. You're like, that might not be 90. So there is a common thing that you see. If you see a little box that looks like that, and I'm putting it in green, that is kind of like the identifier to knowing that it's 90 degrees. So if you see a right angle, there's really only one type of triangle this could be, and you're going to be shocked by its name. A right angle, if there's a right angle in a triangle, that means the triangle is going to be called a right triangle. I know, shocker. So a right triangle, like the other one's, going to have one right angle. And it will look like this, and then just connect the dots. And we would say it would have, just to put in parentheses, one right angle. If we had more than one right angle, we would have a different type of shape. But right triangles have one right angle at 90 degrees. The next angle that we have here is called an acute angle. An acute angle is less than 90 degrees. And I would sometimes get confused with identifying it, so I use the word cute. When I think of the word cute, I think of like a cute little baby. So if it's little baby, it's less than 90. So an acute angle is less than 90. So it would be an angle that looks something similar to like this. And really what I can tell with this, if it's less than 90, if I had an imaginary line right here going up, that would represent 90 degrees. So if it's going this way, it's going to be less than 90. It's going down. So it's less than 90 degrees. And if it's an acute angle, there are really two different types of triangles that you can have there, and that would be a isosceles triangle. So an isosceles triangle, you spell that, I always spell it wrong, I don't know why, but an isosceles triangle and an isosceles triangle has angles that are less than 90 degrees. So it could be something like this. And this would mean all angles are less than 90 degrees. So it can't be, oh, this one's less than 90, this one's more than 90, this one is 90. All of them would have to be less in order to be an isosceles triangle. And then the last angle that we have, if acute angle is less than 90, we also have an obtuse angle, which this time it's greater, obtuse, I think obtuse, big, greater than 90 degrees. So that would be one going the opposite way. So we have maybe like this. And if I was showing a 90 degree, it would be right here. So you see that it's more than 90 degrees. So if it's more than 90 degrees, then we have something that we call a scalene triangle, or it could be a scalene triangle. And a scalene triangle could look something like this. Again, no angles are equal to 90. There could be some that are less than 90 though. So remember, isosceles, all angles are less than 90 degrees. And a scalene, that means there at least one are greater than 90. And another thing to think about is with the angles is important, but you also can think about the sides. So when we think about the sides for scalene, no sides are the same side length. We'll use the word length. Where with the isosceles, almost always two sides are the same size or length. So then when we think about there's two other types of triangles. So we have isosceles, we have scalene, and those are all the angles, but there's two other types of triangles that we see. And the first one is called equal, spelled a little bit different, E-Q-U-I angular. So if I look at that word, I kind of can see that equal, angular. So equiangular means all three angles are the same. And all right, my video got cut off. I've talked for another 20 minutes and realized it wasn't recording. So let's finish up this, our notes right here. We were talking about all three angles are the same and all are less than 90. So that's equal angular, right? Equal angle. Angles are equal. Likewise, you have equilateral right here. Equilateral is where all three sides are the same. So all three sides are the same. So if you look off to the side right here, I drew two shapes. One is where the angles are all the same. They would put a little line or angle circle there. And then if the sides are the same, they're either going to put a line that looks like that, or they might actually put the actual measurement. So it might say 2 inches, 2 inches, 2 inches. And that's how we know it's equilateral. Okay? Then, so when we're trying to identify triangles, we focus on the angles and sides. That's the main thing in doing so. So if you turn in your book to page 660, and like I said, I've already done this whole lesson and I thought it was recording and it wasn't. So let's look at page 660 and let's do these three questions together. Now I recommend keeping this book out to help you, your notebook out to help you, but also on this page you see that they have these to help you as well. Well, look at this first one. It says classify the triangle by its angles and its sides. So if I'm looking at this one, I first look at the angles, and all the angles are the same. So if all the angles are the same, we could put equal angular. I actually put acute too, but let me tell you, if it's equal angular, it's acute. So you don't have to put both. I just did for this case. And remember, acute is less than 90. Equilateral, remember, that is when all the sides are the same. So you could say this is an acute, equal angular, equilateral triangle. Then we have number 2. Immediately when I see this one, I see an angle that's greater than 90. You see that 110, I circled it. That's telling me that it is obtuse. Obtuse angles are that in which we have a greater than 90 degrees. So then I also know it's an isosceles because look at the sides. If you look right here, we have this that's showing this side and this side are equal. So it's obtuse because it's greater than 90. It's isosceles because there's two sides that are the same. And lastly, we have a scaling triangle. Now I made a mark right here, and we would have, if this was 90 degrees, there would be a little box. It said it was 85. So it's less than 90. We can't say it is a right angle. So this is a scaling, acute scaling triangle because every one is less than 90. That's acute. And scaling because all three sides are different sizes. So what I want you to do now is look at the next page, page 661. And I want you to go through those by yourself. Take the next 5 minutes or so, and then we will go over it together. So pause the video and give them about 5 minutes to go over this, and then we will go over it in a moment. So if we look at these, I really break it up into two things, angles and sides. So I always like to identify the angle first, and then identify the sides. So for example, on the first one, what's screaming out to you? For me, it's the right angle right there, right? Because we see that there's a box, we know it's a right angle, so we put right. Then remember scaling, that's dealing with the sides. Sides, are any of the sides the same? Nope. So they're all different, so that would make it scaling. So this is a right scaling triangle. On number 5, like the one on the other page, I have an angle blinking at me. One that's greater than 90. I've circled it in green right here, 96 degrees. So remember, if it's greater than 90, it's going to be obtuse, right? And obtuse is greater than 90. Then I look at the sides and I see that there's 2 sides that are the same, making it an isosceles triangle. So it's an obtuse isosceles triangle. Then the next one, pretty easy one, because look, all the angles are the same, 60, 60, and 60, and all the sides are the same. So it is an equiangular, equilateral triangle. Remember, if you put acute on there too, that's no problem, and all that would be correct as well. So acute, equiangular, equilateral triangle. Number 7, we see that we have 2 angles that are the same and 1 angle that are different, but are all the angles less than 90? They are less than 90, so that would make it an acute angle. And then isosceles, remember that means there's 2 that are the same, so we have one here and here, making it isosceles. So it's an acute isosceles triangle. And lastly, we have the obtuse scaling triangle, or not lastly, but obtuse scaling triangle right here. It's obtuse because the angle is greater than 90. It's scaling because this side, and this side are all different sizes. So it's obtuse scaling triangle. And the last one right here, obviously right here should be blinking at you. It's a right triangle, but then there's 2 equal sides making it isosceles. So it's a right isosceles triangle. So hopefully that helps you a little bit, understand a little bit more. It's okay to use your notebook to help you, but what I want you to try now to end this lesson is page 663, numbers 1 through 6. Page 663, numbers 1 through 6. And once you have finished that, you then can can put that up, and the sub will give you your assignment that you will work on for the remainder of the day. Have a great day. Be on your best behavior, and we will see you tomorrow.